Okay, so let me do the overview first. Okay, this is a chapter 3, which is second law. I think I would just, third law is something that is kind of just added on to the second law. But I want to do the overview. We're going to recap. What is first law? In words or equation, you got two options. The most simplified equation that you can see. Anyone can say what the first law of thermodynamics?
U equals Q plus W.
U equal Q plus W. There's something missing here, which is?
Oh, delta U.
That's right. So change in the, because this is a one state to the other, and the Q and the work are related. And one way to call this is, it's called the energy conservation. Energy conservation is the first law, right? So that's the one that we talked about. So we actually just talking about how energy transaction in and out. And this is a pretty intuitive in a way, how can you create the energies and so on. What is the second law? Has anyone heard about second law? I mean, at least you heard the term before, right? And this is about, I would say, spontaneous change. Which is spontaneous? Which is what change is spontaneous? What change is actually not spontaneous? Well, not going to happen, and that's the one that I'm going to show. Is anyone heard about? I'm just want to see that is any equation you kind of heard about it. Entropy increases is like a spontaneous direction. Delta G goes down. The equilibrium energy. So somebody will say, well, that I think I heard about entropy is increasing it, or somebody heard about delta G is decreasing it. These are the direction for the change. And one of the equations is wrong. And that's what I want to change. So I think in a general sense, I think many sort of the naive class say, oh, entropy is always happening in a direction for increasing the entropy. That's a natural direction to change. The answer is actually no. Okay, so that I want to change that, and because that's a real statement, not correct statement. The one that is correct is this. Okay. The one that is not correct is this. This is actually being very ambiguous. The only equation that makes sense, that it is true, is total. Okay? Entropy of the total, which is a system plus surrounding. So the total system plus surrounding. This is let's say this is a one, that this is a system, this is a surrounding. So everything together is a total. And what's the correct statement is entropy of the total is always happening in a direction for increasing. Okay? So and then the one thing that also says this one is actually, we just simply say S. Okay? Just put surrounding. Because eventually our focus, our interest is always focused on the system. So this is, when you just simply say S, that means that you're talking about entropy of the system. And so does this. And I don't need to write that this is system Gibbs free energy. We're just showing it. So that's why the beauties of the Gibbs free energy is you can focus on system. Right? You can still stick to the entropy description to see whether the process is spontaneous or not, but you have to consider both surrounding and the system to see if this is actually true. Okay? So let's say I'm making this is a kind of a not an equation way, but kind of comment. Let's say you have a room, right? You leave your room. If you leave your room and room gets messy and messy, right? Entropy goes up, and I think that's a natural direction for change, right? That's probably what you kind of somebody give one. But I would like to challenge that comment. So let's say one day you decide your mind, you're going to clean up and make things put in the right places. Everything is nicely organized. So what happened to that your system of your room? Entropy actually went down, right? The degree of chaos is the chaotic state. Disorderness came down. Is that process spontaneous? You just clean up your room.
Well, it's not spontaneous for me because I'm not doing it.
What?
It's not spontaneous.
No. The fact that you did it is, and that this thing ever happened, that's a spontaneous, right? Entropy can go down to make it more ordered, but there is something that you forgot. There is an entropy increase on the other side of this equation that you do. You make your room clean and nicely ordered at the expenses of, I guess, you're burning calories, and I think you're something other inside is something more chaotic. So overall, not just the room, the person working there and the surrounding, if you count both of them, both combined entropy is always going up. And it's always that's for the change. That is our first comment, and let's get this one.